Have you ever dreamt of traveling through time? I'm sure we all have. Maybe you want to go back to the past to see how things were or even change something. Or would you prefer to go into the future to see how things turned out? Time travel is a mainstay of science fiction, with books and movies imagining the benefits and risks of such an ability. But is time travel actually possible? And if so, what do we need to be able to do it? To understand how we might go about traveling through time, we must first understand what time is. Classical physics saw the concept of time as something that exists for everyone, everywhere in the universe. It's independent of any who perceive it and progresses at the same pace for everyone. It means that a cause is always followed by an effect, never the other way around, something that the structure of the universe relies upon. The problem with this understanding of time, though, is that it doesn't hold true in all circumstances. That is why Einstein's theory of relativity is seen as one of the most important scientific breakthroughs ever, because it explains the changing nature of time. The theory of relativity sees time as one element of four-dimensional space-time and can be influenced by other factors. Objects moving at high speed, for example, experience time slower than those moving with less velocity, and there's a similar effect for objects held within gravitational fields. On a human level, this means that an astronaut orbiting the Earth will age slower than those of us that remain on the planet, but there are far more unexpected consequences of this. Take black holes, for example. They exert the greatest gravitational pulls of any known object in the universe. They are so strong that light itself cannot escape, and also causes time to slow down to an extreme level. If you were to, say, pull a Matthew McConaughey and fall into a black hole while looking out to the rest of the universe, you would in theory witness hundreds of millions of years worth of events before ultimately succumbing to your inevitable fate, or get trapped behind some bookshelves. If it were even possible to escape a black hole, so much time would have passed on the outside that life would be completely unrecognizable. Another quirk of time occurs with the speed of light. As you get faster and faster, time slows down for you, and this continues until you reach the theoretical maximum speed that anything can reach, the speed of light. At this speed, time has slowed to such an extent that things seemingly happen instantaneously. Imagine, for example, a photon of light that is emitted by a star on the other side of the universe. It will take, even at its incredible speed, many millions of years to reach us on Earth and be seen by our eyes as a twinkle in the sky. For the photon, though, the journey is instantaneous. It is created and then it reached us in the same instant. When traveling at the speed of light, time is neutral. It travels neither forward or backward. So if the faster you go, the slower time appears for you compared to everything else, then this is a potential route to traveling forward in time. You could speed away from Earth and return, and many years will pass without you getting much older. The really difficult part, of course, is going backwards in time. If at the speed of light, time is stagnant, then does that mean if you were to travel faster than the speed of light, then would time work in reverse? Many researchers think so, and there is a theory that there is actually a subatomic particle that does exactly this, known as a tachyon. These particles are theoretical and have never actually been observed, partly because if the theory is true, you would never be able to see them coming towards you, as this event would be occurring in the future. The ideas of cause and effect would work in reverse for tachyons, but there are those that believe that harnessing them could be the best route to learning how to travel through time. Another theory is that of wormholes. These act as tunnels through the fabric of space-time and could create a path between any two places at any given time. The theory of relativity actually allows for wormholes to exist, but states that the energy levels required to create one would be astronomical and could result in the formation of a black hole. Stephen Hawking believed that the radiation feedback, which works in a similar way to the feedback of sound, would make wormholes inherently unstable and unable to last a long enough time to be used as a time machine. Other researchers have suggested a number of ways in which spacetime could be harnessed to allow time travel. Perhaps lasers could be used to create extreme levels of gravity. Quantum physics may allow for the formation of a so-called quantum tunnel between universes, and perhaps string theory might lead to revelations of how cosmic strings and black holes could intertwine to warp spacetime enough to travel back through time. In conclusion, the notion of time travel has long been of interest to researchers, and all of us was at some point or another, and for a long time it was thought to be completely impossible. With advances in our understanding about the universe in the last century, it's no longer seen as completely impossible, but it's still an ability that lies well beyond our current capabilities. The law of physics do allow for it to happen, and it could very well in the future be something that becomes more of a fact than fiction. But let me know what you guys think. Do you believe time travel has already been invented and there are now time travelers among us? Thank you all so much for watching. See you next time.